In this lesson, you'll write your very first SQL queries for actually joining tables. Once again, I highly recommend following along and trying the code alongside me with your own notebook. So I would suggest navigating Data Hub, opening a new notebook, and just like I'm going to do here, load up the SQL extension. Then you should connect to the SQLite database, and we're ready to go. First up, let's create these two tables that we'll use throughout this lesson. So I'm going to type that here, create table. I'm going to create from left to right. Oops, let's always use our cell magic here. Create table breed. We're gonna have two columns here: integer, primary key, auto increment, name, text, not null. Even though I didn't specify these constraints, primary key, auto increment, or not null in the schema on the left, I would suggest doing that for any field that is mandatory, and then for your primary key. All right, let's go ahead and insert data in. So insert into breed, and this time I'm gonna specifically say that we're only inserting the name. So we're gonna let the ID column self-populate. And you can do that by just adding the parentheses and adding any fields that you want to actually specify in your query right after it. So here we're going to have just the name. So Corgi, we're going to have Bernese, and Bulldog. And let's now create the pet table as well. So here we'll have three different columns: ID, integer, primary key, auto increment, and then the breed ID, not null, and finally the name. You'll notice that for foreign keys, we don't actually have to specify. There is no such thing as a foreign key constraint here, so we'll just specify integer, not null. All right, and now let's insert into pet, and we're going to specify only the breed ID and the name. We'll let IDs self-populate. So here we'll have 1 apricot and 2 boots. All right, so now we've got these. Once again, if you make a mistake and you need to rerun these cells, go ahead and type here drop table breed, drop table if exists breed, and same thing here, but for pet. And that will allow you to run the cell as many times as you need to. All right, so let's move on to the actual content, the new content. So we're going to now first implement a cross join. A cross join selects all pairs of rows. So as you can see here in the example, we have the two tables that we created, and after the gray arrow down below, you'll see that it's combined all possible pairs of pets and breeds. So let's try that now on the right hand side. Select all, your cell magic, select all from pet. I'll just say pet breed here. Right, and then you can also add the aliases that I have over there. So, and you'll get the following. The table looks exactly the same. The only thing that will change, as you'll see later, is how we reference these tables using these aliases. All right, so that's it for a cross join, all pairs of rows. Now let's talk about an inner join. An inner join only selects matching rows. So if you look at our query there, you'll notice that we join both the pet, or we take the pet table, we join on the breed table, and then we specify a predicate. We specify that the breed ID for the pet must match the ID for the breed. Right, so if you look at the top half example here, you'll see that we've crossed out the bulldog because there are no pets that correspond to a bulldog. So we're going to leave that out. And down below is the result. We only have each pet and their corresponding breed. So let's try this now. On the right hand side, we'll type in select all from pet as P, join the breed table on this predicate. And there we go. We have the two rows that we'd expect. Let's keep going. Now, an inner join is actually a cross join, so it's all pairs of rows plus a filter. Now this is only conceptual, but you can get the exact same result by doing what we have here on the left. We're actually, oopsie. All right, let's try out this query on the right-hand side. Here we're going to specify our cell magic, select all from pet as P, breed as B, where p.breedid equals to b.id. And again, we have the exact same results as before. So we're now going to use a left outer join, which selects all rows in the first table. In this case, we're selecting from breed. So breed is the first table. We're going to include all rows in breed, regardless of whether or not it matches a column or row in pet. So here, you'll notice that we no longer cross off bulldog, even though there's no matching pet. So in the results, we'll actually include bulldog and then an empty row. Right, so let's go ahead and give this a shot. Null means empty. SellMagick select all from breed as B, left join, pet as P, and on p.id equals to b.id. So actually this is not correct. My bad. This is p.breedid. And here you'll notice that the bulldog is empty. So translated into Python, null becomes none. All right. And the practical tip is to use outer joins, like the one that we just did, to account for rows with no relationships. For example, let's say that you're reporting the number of orders, let's say delivery, or grocery orders per user. Inner join would omit any user that doesn't have any orders. So you'll want to use an outer join if you want to report users and include users that have 0 orders. You can also flip this around. So instead of doing a left outer join, you could do a right outer join. So here we'll include all rows in the second table. Now note this is not supported in SQLite, so we're not going to have a demo for this on the right, unfortunately. But same idea, there's going to be some missing empty values and those values will be null. There's also a full outer join, so include all rows in both tables, and so you can imagine you'll just have nulls on both sides. So here, as we show below, you have empty values on the left, empty values on the right. And unfortunately, this is also not supported in SQLite, so we're not going to have a demo for this. Now here's a quick check. Give this problem a shot. Take a student table and a signups table, which maps students to classes. Which join do you use to report the number of classes per student? So again, your options are a cross join, inner join, left outer join, right outer join, or a full outer join. So give this a shot. Take a second to pause the video and try. All right, and now here's the answer. The answer is, depending on whether you select the student table first or the signups table first, it's going to be one of your outer joins. So here I've said left outer join if we have selected from the student table and joined on signups. If you selected signups and joined on student, then you would have a right outer join to account for students with 0 classes, right? So remember, if we do an inner join here, we're going to omit any students that don't have any signups in their many-to-one relationships table. All right, now let's take the exact same scenario, but we now have a different question. We're going to take a student table and a signups table, which maps students to classes. Which join do you use to check that no student has exceeded the maximum 6 allowed classes? Pause the video here and give it a shot. All right, and now here's the answer. So we're only interested in students that have exceeded the maximum 6 allowed classes. So this means we don't care about students that don't have any signups. So we're going to use an inner join to be most effective, as we only look for students with greater than 6 signups. All right, now let's cover the last section of this lesson, which is join predicates. So the join predicates the join predicates don't have to be an equality. So we've talked about equality predicates so far in the on condition, but here you'll notice that you can actually do this with a greater than as well. So I'm going to speed through really quickly to also show you this demo on the right. So I'm going to create these tables. All right. So now we've got our 2 tables. Let's try this query. And there we go. We have the table that we expected in the bottom there. We have any pair of students and teachers where student age is greater than teacher age. All right. Let's try another quick check. So for each penguin, find all possible parents. The table down here is our table of penguins. Let's just pretend the table name is penguin with a capital P. So for each penguin, find all possible parents. A possible parent is a penguin that is older, basically. So you're looking for all penguins that are older for each penguin. Pause the video here, give it a shot. All right, and now here's the answer. I'm going to start off by typing out this table. And there we go. All right, so now we can actually try this problem. So let me show you on the next page here. We have the following query where we select from Penguin as child, and then we join on Penguin itself again, but this time it has the alias parent. And finally, our join predicate is that the child age is less than the parent age. Here, this is called a self-join, where we join on the same table that we're selecting from. Let's give this a shot. So select from, and there we go. We have a bunch of possibilities. It's a lot of possibilities there. Here down below in smaller font, I've actually included another way of doing this problem. This is if you used a cross join instead of an inner join to do this problem with a filter. I wouldn't recommend this. This is less efficient. So whenever you can, use the inner join. All right, so the takeaway is use outer joins to account for rows with no relationships. Sorry, this is the takeaway for the entire lesson, not just for the last quick check. So again, use outer joins when you have rows with no relationships, like a user with no orders or a student with no class signups. And that's it.